In this video, we're going to focus on 3 ways of proving this formula. This is a formula of a length of a bisector in a triangle. And the first idea to prove this formula is using the circumscribed circle of a triangle and similar triangles. Let's extend the bisector of a triangle until it crosses the circle. And let's also draw this chord. We can see that these two inscribed angles are equal to each other, which gives us a couple of similar triangles. Namely, these two triangles are similar because these inscribed angles are also equal to each other, and if we call this segment X, we can state that the ratio of these two corresponding sides is the same as the ratio of these two corresponding sides. So L plus X over B equals C over L. Now we have to eliminate X, and to do that we need another pair of similar triangles. We can see that the green triangle is also similar to this small triangle here. So the ratio of these two corresponding sides equals the ratio of these two corresponding sides, which means that X over M equals N over. Now we can express X from this proportion. It is equal to Mn over. And if we plug X into this proportion, we're gonna have that. Now we just have to use the cross product property of this proportion. We're gonna have L squared plus Mn over L multiplied by L, which is just Mn, and this all equals BC. This means that L squared equals BC minus Mn, which obviously implies the original formula that we wanted to prove. This proof, in my opinion, is the most elegant because it requires the least amount of evaluation. Now let's move to the second proof. We're going to be using the cosine rule and the bisector theorem. Let me remind you that the angle bisector of a triangle divides the opposites into two parts that are proportional to the other two sides of a triangle. So for our situation, we can state that B over C equals M over N. Now let's name these angles alpha and let's write down the cosine rule for each of these two triangles. We're going to have M squared equals B squared plus L squared minus 2 times B times L times cosine of alpha, and something similar for the second triangle. Now obviously we don't need the cosine in our formula, so we have to get rid of it. And to do that, I'm gonna multiply this equation by C and this equation by B, and then I'm gonna subtract one equation from another. I'm gonna have M squared multiplied by C minus N squared multiplied by, and this is all equal to B squared C minus BC squared plus L squared C minus L squared B. Now we have an equation with unknown variable, so we need to solve this equation. Let's shift these two terms to the left-hand side of the equation, and let's also use the fact that MC equals Bn. We're gonna plug MC into this term, which will give us M times Bn. And we're gonna plug NB into this term, which will give us N times MC. Now we can see that these two terms have a common factor of Mn. So the full equation will look something like that. And if we now take out the common factor and do that to these two terms as well, we will have that. Now we can divide both sides of the equation by B minus C, which will give us Mn minus Bc equals minus L squared. So now we just have to multiply both sides by the -1, so we will have L squared equals Bc minus Mn, which again implies the original formula. Thus, we have proven the formula of the length of the angle bisector of a triangle. And our final third way of proving this formula involves using Stewart's theorem. We're going to need to name the third side of a triangle A, and Stewart's theorem states that the relation between the length of a Chevian and the sides of the triangle is given by this form. So once again, we just have to solve a quadratic equation with variable L. If we divide both sides of this equation by A, which is equal to M plus N, then for this factor of the right-hand side of the equation, we will have L squared plus Mn equal B squared N divided by M plus C squared M divided by M plus, and let's just evaluate this expression. We just need to prove that it is equal to, so once again we will use the bisector theorem, which implies that Bn equals Cm. And once again, if we plug Bn into here and Cm into here, then we're gonna have Bc divided by M plus Bcn divided by M plus. We have a common factor of Bc, so let's factorize this expression. We're gonna have Bc multiplied by N divided by M plus N divided by M plus N. And this obviously is equal to 1. So this whole expression is equal to Bc. And there we have it, L squared plus Mn equals Bc. Or in other words, L squared equals Bc minus M, which proves the original formula. So thank you for watching this video. I hope you learned something new. I hope you enjoyed it. See you in the next one.